Good evening. Good evening, all.
Good evening.
So, I'm Kamal Prajapati from Secure Meters. I am very thankful to Professor Joshi, Chairman, Mr. Keyur Thakkar Saab, Honorable Secretary, and Dr. Hireni Mankodi, Honorable Secretary of Institute of Engineers, for inviting us and share our thoughts. So today's presentation, or the discussion, I would say, the discussion topic is energy transition is equal to energy security. So what do we mean by energy transition and energy security? I will give a brief highlight about this. So with me, Mr. Sanket Patel is also here, who is our technical manager for the domain of water services, because I am having some short stories about water services. We have some short stories of successful energy efficiency program in the water services domain. So Mr. Sanket Patel will help me to present that. So today's presentation will cover the brief about secure, what is secure, and energy transition scenario with a global perspective, with Indian perspective. And we will be presenting two parts, energy efficiency and upgrading infrastructure, which is actually helpful in energy transition and the getting energy security. We will present some case studies, successful case studies in the energy efficiency and the upgrading infrastructure domain. So this is how we will go in the presentation today. So let's start with the secure meters. What is secure meters? Generally, people knows secure meters as a grid meters manufacturer, because secure meter has a very reliable grid meters, and people in Gujarat especially, people use energy meter for the grid domain of secure meters. So apart from that grid meter, secure is very wide. So what is that? And what are we doing in different domain that I am presenting. So Secure's innovative solutions are there to ensure the sustainable future. So we have started in 1987. So I'm proudly saying that we are a multinational company, Indian multinational company, who is doing more than 50% of its business from the export. So we are contributing to the Indian economy as well. So we started in 1987, and we were the first manufacturer of electronic meter in India, and we have adopted technology from the UK. So we adopted technology from PRI company from UK, and then we have manufactured our own electronic meter in 1987. Then we have started our journey. We have acquired many companies because we got a success in this particular domain. So you can see between 92 and 96 we have acquired two companies, PRI and CV. Then we have introduced prepayment in between 1997 and 2001. Between 2002 and 2007 we have acquired many companies like iProbe, CV, Ames, EMS. Between 2007 to 22 we have Utilita, Hotsman, which is a smart thermostat company in the UK. In Australia, we have, again in UK, we have acquired a company called Redboat. We have recently acquired a company called Adaptricity from Switzerland, which is actually doing the grid, which is doing a planner, which is a cloud-based solution company, and giving solution for the grid domain to monitor, simulate, and it helps actually distribution company to better plan their distribution network. So today, as a secure meter, we are doing business with 5 entities: Secure Meters Australia, Secure Meters India, Sweden, UK, and Middle East. So there are different companies which we are operating under Secure Group. So I would say at this moment I recall one शायरी from Majroor Sultanpuri. मैं अकेले ही चला था गालिब, लोग साथ आते गए और कारवा बनता गया. So we are a truly multinational company who are actually originated in India and export doing export business apart from metering. So this is our presence. You can see our market and our presence in the flag. So we are proudly saying that we are present in more than 60 countries, and we are the largest exporter of energy meters from India. We are among worldwide top 3 players in the grid domain and number 1 in India for the grid domain. And we have offices in our India, UK, Sweden, Italy, Switzerland, Australia, Dubai, Bangladesh. So we are a multinational company, and we have supplied more than 5 crore meters till now. And we have supplied more than 2 crore smart meters till now. We are doing metering, billing and collection services as well. And we are into energy auditing and the services business as well. And we are proudly saying that we have about 650 plus R&D engineers. So largest R&D in the metering domain we have, and about 6,500 people working around the globe. And these are our workplaces. In India, we have 3 manufacturing facilities, one in Udaipur, Rajasthan, Sanand, Ahmedabad, Solan, Himachal Pradesh, and then we have a R&D unit and logistics unit in Gurgaon as well. In UK, we have 2 facilities, one in Bristol and Nestle. Sweden, we have acquired a company called CV. The design team resides there in Sweden. Australia, we have a logistics facility. UAE, Bangladesh, Switzerland, as I said, Zurich in Switzerland, we have acquired a company called Adaptercity. And we have a new manufacturing facility in Italy recently. In 2022, we have designed. So we are a global company. And these are our footprint as far as smart meterings are concerned. So we have started way back in 1999 as far as smart meterings are concerned, and these are our global footprint. So we believe in prove ourselves first, and then we give the benefit to the company, and then we expand our business. So that is our strategy. These are some manufacturing glimpse of our state-of-the-art factory, the molding facility, the testing facility, and we are proudly saying that we believe in our technology, we believe in our quality. That's why we are giving 10 years no payable warranty on our most of the electronic products. So now, if you go to the market for the meters, you will get 12 months, 18 months, or maximum 24 months warranty. But without asking anything, Secure Meter is saying that on all the electronic product, we are giving you 10 years warranty. So that's the achievement which we have got from our production people. And these are the different products which we deal with. So these meters we all know. Grid meters, distribution meters, panel meters, transducers, communication devices, consumer meters, single phase, 3-phase meter, prepaid meters, smart meters, and HVAC control as well. So we have few devices, intelligent devices, which works in HVAC control as well. So, okay, so that was a brief introduction about secure meters. Now let's start our journey to understand and actually to debate and get knowledge from each other about energy transition and energy security. So the global scenario. So what is energy transition or energy security? So the uninterrupted availability of energy sources at an affordable price. So as per International Energy Agency, the definition is uninterrupted availability of energy sources at an affordable prices. So if we achieve this, we will say that the energy security is achieved. So far what happened in the global domain, people have taken short-term measures. Short-term measures like they have changed their fuel type, they have changed some market, they did some market interventions, like change some rule in the grid domain. Say, let's say in India we have introduced open access, GDAM, group green day ahead market scheduling. So those kind of measures. Financial measures, like if you are using electricity at this time, you will be charged more. Then voluntary demand reduction. So that those were short-term measures which is taken by the global companies or global countries. But what would be the long-term measures? The long-term measures would be the goal to attain the sustainability. And the challenge in this advanced technology, still people are working hard to get the solution for this technology, so that we can get rid of this coal-based generation to get the inertia in the grid, right? Advancing the technology, change in the fuel, multi-stakeholder collaboration. So everybody has to collaborate. So that's a challenge, because we have seen the Ukraine war, we are seeing now the Israel war. So if until the global the countries do not collaborate, this will not happen. So collaboration is very important. If we see at Indian perspective, we have neighboring countries which we have to have a good partnership. Then only we will get the collaboration. Involve everyone. So companies, international organizations, and consumers, everybody has to involve. It will not, like a silo will not work. So if, let's say, energy companies or let's say government are putting their efforts, it will not work. Energy companies, industries, consumers, everybody has to participate. So I would say integral element of successful energy transition. So energy transition needs energy security, affordability, and most importantly, sustainable to meet global climate change. So this sustainability is very important. So the few choices country has made so far is improve their energy efficiency. So they have started improving their energy efficiency, like in US and European countries, in Australia as well. In India, they have started now. So ESCO models are arriving. Like if you are improving your energy efficiency in your industry, you will get some benefits from the government, and those kind of drives has been taken. Then scaling renewables that we have so far seen in India as well. We are scaling our renewable energy generation. So those were the few choices which we have adopted, and there are few actions as well globally which are impacting this path, which are increased electricity from coal. So electricity generation from coal is also increasing, and there is no sufficient investment being done globally. So that is also a problem. So to pursue the energy transition at a pace, we need short-term intervention, but that should align with the climate change. So that's the solution. So this graph shows that from 1850, how the global temperature, Earth's temperature has been rising. So you can see a stiff curve from 1980. So after industrialization, this curve is constantly increasing, and now the temperature is around 1.1 degree or 1.2 degree now. So we are trying to keep it under 1.5 degree. So there is also one fact that globally the top 10% of households which are using consumers, like already developed countries, in already developed countries, the top 10% of the consumers are using 20 times more energy than the underdeveloped and the developing countries, right? So that's again a fact to be looked into. So energy security is basically energy triangle. So security, sustainability, and equity. Security we have seen so far. Sustainability, we need a sustainable solution, right? And equity is very important over here, that energy system in which energy is fairly distributed. So energy distribution should be fair, and it should be accessible to and affordable to everyone, right? So few countries are taking advantage of it, that will not work, right? So, and the initiatives benefits, like sustainability initiative benefits to be shared across the community, across the globe. And now, this was the problem. Now, what should be the solution? So, there are 6 dimensions which has been drafted for the successful energy transition. And this is actually a framework to get, successful energy transition. First of all is system stability. So, we are adding more and more renewables into the grid, but stability of the system is very important, as we were discussing before this seminar, that inertia of the system is very important. So to get the inertia, we are using more and more coal-fired plants, so that we get the inertia. We are having the industrial boom as well, because the demand is being increasing like anything. So system stability is important. We need to achieve the system stability by adequate dispatchable generations and demand response. Global and regional trust should be there. So we need to strengthen our collaboration as I discussed, and we need to build trust among each other, and we need to trade like carbon credit. So for the carbon credit we need to trade. So market and regulatory measures in India, we have seen so far this GDAM, MBED policies, BSES funding. So BSES funding, BSES is a battery storage energy system, is very expensive solution to get the grid stability. We need the BSES kind of solutions. So government are funding for this, for these particular solutions. So market and regulation measure has to be done. Cyber security has to be checked, because by 2050 most of the things or most of the energy would be used from the electricity form. So system security is important, supply security is important, and demand management. So that was a global perspective how we can achieve this. At Indian perspective, the Panchamrit goal was declared by Indian government in COP26 2021. Government of India or Modi government has finalized this 5 goal to increase the non-fossil fuel generation to 500 gigawatt by 2030. So far we have attained 183 gigawatt, and our demand is 420. So installed capacity is 421 gigawatt by July 23. We need to meet 50% of energy requirement from renewable by 2030. Reduce total projected carbon emissions from 22 to through 2030 by 1 billion metric ton, and reduce the carbon intensity by 45% by 2030 compared to 2005. So energy intensity we need to, carbon intensity we need to reduce. Achieve the target of net zero by 2070. So these are the Panchamrit which was declared by Government of India, and government is working towards that. These are few of the chart. The importance of this chart is the gross generation is at present, the gross generation curve you can see about 70% of electricity is from the coal or thermal, and by 2030 we want to achieve it we need to reduce this to 54%. So this is our goal. So fossil fuel generation we are at 59% right now. We want to reduce it to 36%, and this is how the technology will work when by 2030. So this yellow is basically from the renewable sources or solar plants. So this kind of generation pattern would be there by 2030, and you can see here year-wise estimated emission in metric ton. So here we are at 1002, and we will be ending up at 1114 by 2030. So this would be the base load in 2030 as per plan. So about 27% of energy would be used from the renewable sources, and this is how we will be reducing our emission factor. So this is the Indian goal. One important thing is this is the normal load pattern of India. So you can see there are morning peak and there are evening peak in our load. So this peak has to be flattened if we want to secure the energy. So to flatten this peak, definitely this smart metering will help, because I will further explain about smart metering concept in India. So smart metering and the TOU wise tariff will help in flattening this load curve, and this will ultimately help in reducing our base load capacity. So this is how the normal consumer can help, or in this sustainability goal. So switch to transport mode, like we will be going further using in the EV electric vehicles. We need to increase the digitization. So we need to use smart meters, we need to have mobile app, we need to analyze our consumption, and then we need to act upon. So now we have seen so far how this energy security will have, how this transition will be done, and how we will achieve the energy security. So technologically, how we can help secure, how secure can help. So we can help in improving the infrastructure and we can improve the energy efficiency. So improving infrastructure by smart metering and the PQ solutions. And the energy efficiency, we have a couple of case studies where we have used the technology to improve the energy efficiency. Part 1 is achieving the goal, improving infrastructure. So most of all, we know what is the power quality, but just to emphasize more that we have electrified everything, now we have available power. So when this power is 24/7 available, we can say that the power is reliable. But if this 24/7 power is available in a proper quality, then we can say that this power quality is accepted and we can have the satisfied customer. So power quality, by power quality I mean the voltage harmonic dips, interruptions, those things. So if you buy anything in market like a simple milk bottle, we see the different facts about what are the nutritions we are going to get out of this milk. But what about power? We don't care about that. Distribution company has connected the power to our home, but we we do not care about what is the power quality. So but when we talk about a specific industries like data centers and IT manufacturing industries, or like there is a big plant coming up in Ahmedabad, Micron chip manufacturing plant. So these are the plants which are very specific about power quality. So if as a distribution company, if you are going to supply the power to Micron chip plant, they will definitely ask you about the power quality parameters. What are the power quality parameters you are going to connect to my factory? So this is very important now to comply to the power quality regulations, because power quality parameters, you will see definitely sag and swell, you cannot avoid in the system sag and swell, but there has to be certain limit for that, right? So the power quality parameters are continuity of supply, 24/7 the supply should be available. The magnitude of supply, if it is 220 kV connection or 132 kV connection at factory, it should be plus or minus 10% or whatever limit is explained in the regulation. It should not be beyond that. So magnitude of supply should be stable, frequency should be stable, waveform should be pure sinusoidal, and symmetry across the phases. So that has to be there. And to verify that, there are a couple of power quality parameters which needs to be measured, like interruptions, sag, swell, flicker, under voltage, over voltage, rapid voltage change, right? Harmonics, interharmonics. So those are the parameters which we need to measure apart from the traditional parameter like kWh, demand, power factor, active power factor, right? And these are the contributions towards the poor power quality, as we know. Residential loads, CFL, lamps, air conditions, inverter-based air conditions, right? So anything which is changing electricity supply from AC to DC and DC to AC, it will introduce some sort of harmonic or some sort, it will distort the waveform of your signal. So there has to be mechanism to measure that, and once you measure that, you can verify and you can correct that by using different solutions. So this is just a small representation about how the harmonic is impacting your waveform. So as the harmonic increases in your original waveform, you can see the sinusoidal waveform is becoming the square waveform, right? So this is impacting, and definitely your machines and the equipment which you are using, it is not designed to tolerate this waveform. So traditionally we were measuring the power factor and the reactive power, and we have to now be conscious about measurement of the power quality parameters as well. So as Sir has said, in somewhere in 18th century, we have started generating the power. Then now in 1990, we have introduced some non-sinusoidal waveform sort of equipment or generator, which is not fit for our distribution network. So at that point of time, the amount of these kind of generators were very less, but now it is huge. So after 2010, it is becoming a concern now. So this is again a fact that if you improve your energy efficiency, at the same time you're degrading the power quality, right? So illumination, you have changed from filament bulb to LED bulb. Process plant, you are using VFD. Railways, you are using, yeah. So converters, automobiles, you are using EV. So the power quality has to be measured right now. So why, what complicates? So we need, the present infrastructure is not ready or not fit for this. We have to improve the infrastructure, right? And to PQ measurement and grid points are essential to measure the power quality parameter. And that's, yeah. So at the right hand side, you can see the system was unidirectional. The power was coming from up top to the bottom, but now it's bidirectional. Yeah. So that was brief about power quality parameters. Now we have a device which can measure the power quality, and in fact, in India, CEA, Central Electricity Authority, has in 2019 they have drafted a regulation and finalized that each point which is connected to the grid at 11 kV and above, they have to measure the power quality parameter and share the data with respective distribution company and respective transmission company, so that if there is any problem, they can identify the problem and normalize that. So CEA has notified that, and there are states who have already declared or already incorporated this one in the grid codes, like Tamil Nadu, Maharashtra, Punjab, and now some actions are happening in Gujarat as well, that all the connections at 11 kV and above, they have to install the power quality so that the grid discipline can be maintained. This is a short story to verify or to see what is the impact of those machines which are generating the harmonic on the grid. So there is a regulation called, or compliance regulation called IEEE 519, which talks about harmonic, what is the permissible harmonic you can inject into the grid. So definitely you cannot completely remove that, but if you want to comply that, then IEEE 519 is the standard, right? So there was an electronic manufacturing industry who was trying to identify where I am standing in front of or against this IEEE 519 regulation, whether I am complying or not, whether I am generating harmonic and giving to the grid or not. So we have installed a meter, and what we have seen so far is the supply quality from the utility side was perfectly fine. There was no issue in that. But at the factory side, they were using so much UPS. So many UPS they were using, and this UPS was actually generating some sort of harmonics. And due to that, IEEE 519 compliance was failed, right? So that's what we have identified, and the dominating harmonic was 5th, 7th, and 11th, and 13th in reducing order. So these are the graph we have captured from the meter. You can see the dominating harmonics are there. So 5th harmonic is dominating about 10%. And what we have identified is there are some sort of sags and swells also onto the systems, but it is under the permissible limit. So voltage supply quality is good. So after this case study, they were able to identify the problem, and they have actually, what they did is, in their UPS some harmonic filter was there, passive harmonic filter was there, which they did not switch on. So they switch on that filters, and then they got some sort of correction in that particular waveform. But still we have said that you need to give the proper attention in this. Second, so that was electronic industry. Now industries, we all agree industries are using variable frequency drive. We come across an industry who are facing a regular problem in line stoppages, but they were not able to identify what is the actual problem. So what we did is we installed this power quality meter, and what we found is there was a voltage dip event, voltage sag, which was more than 200 millisecond, and it was reduced from 63%, less than 63% of the nominal voltages. This sag is actually creating a problem in their variable frequency drives, and they are getting the frequent stoppages. So this is how the solution helps. There is one more thing, like if you are an industry, you are not generating any sort of harmonic. You are, let's say, you have not installed any sort of machines which is generating the harmonic, but nearby you there is a factory of, let's say, steel industry which is generating harmonic. So this harmonic will be fed to your industry, and you will be seeing that total kWh consumption will be higher than the fundamental. So you will be charged more from the utility if total energy is being used for the billing. So that sort of scenario, to address that sort of scenario, in this solution we have a facility to verify that whether this harmonic energy is from supply side or from the utility side. So utility side or from the customer side. So that is there. So that's how the utility will or industry will get benefited, that where and what to be addressed, what problems to be addressed. So as we have seen that different utilities has already implemented this in grid code, like power factor penalty or maximum demand penalty. You will see the power quality penalty as well, right? So this meter has to be a revenue compliant meter or tariff compliant meter. So we designed a combined meter which does the revenue metering and the power quality metering, and there are various advantages with this particular solution. And this solution was awarded as best product design product in 2018 ELECRAMA as well. So this is a small demonstration about from generator we got a sinusoidal waveform, but at the load side where marriage happens between current harmonics and the supply impedance, and then you will see the voltage harmonic is generated, or you will see the voltage harmonic recorded in your device. Yeah. So there are some voltage visible cost of this harmonic, and there are some invisible cost as well. Right? So it's a silent feeder. So why this power quality? It's a need of a time. I think regulatory and people are working since last 5-6 years, and I think you will see in next 2 years you will see this will be there in most of the utilities. Yeah. Now smart metering. Smart metering, as we seen, smart metering has a significant role to play in energy security, and it will provide a near real-time information to enable the user to act upon. It will empower the consumer to change energy usage pattern, and when consumer reduces or shift their energy usage, it will support the energy security. So customers can be rewarded for reducing their peak load. There is a scheme called RDSS in India, which is having a goal by which government is funding those RDSS project. So revamped distribution scheme is been launched. So the objective is to reduce the AT&C losses by 20 to 15% by 24-25, and reduce the ACS and ARR gap, and it needs to be near to zero. So that is the objective in this particular of this particular scheme. So this is the driver for the smart meters in India. So this RDSS scheme tenders has been floating in India, and people or utilities are supported by companies like us, and we are delivering the smart metering solution. So what is changed in these smart meters? Traditionally we were doing like this. We were using energy, meter reading takes place, billing prepared, bill distribution will happen, bill collection and payment collection will happen. This is how it will be running. But in this new prepaid scenario, what will happen? You need to recharge your meter with a certain amount of payment, and then you will receive a token. So this token needs to be fed into the meter, and then meter will be recharged with that particular amount, and then you will use. So until you do not have the sufficient balance in your meter, you will not be able to use the electricity. So that is how prepaid concept will work. And this smart metering scenario, what will happen is this prepaid meter or smart meter, we call it a smart meter, and utility office will be backed by a communication device and communication network, which we call as an advanced metering infrastructure. So this AMI facilities are there, and how they will reduce the AT&C losses. So they will prioritize the area where the AT&C losses are higher. They will prioritize those area. Feeder and DT meters will be first metered. Consumer meters will be metered through smart meters. Data analysis will be done, and then loss reduction will be done. So this is the journey which will happen with the use of smart metering infrastructure. So by smart meter, what we see is it's a smart meter. It will be a communication network. there will be some head-end system which will take data from meter. There will be some meter data management system, and there will be some in-home display unit. It may be your mobile app, which will use by customer and reduce their consumption pattern. And by smart meter, we, as per IS 16444 standard, by smart meter it's a static meter with some load switch, because you need to disconnect the load as well. So there will be some load switch. There will be some communication module which will communicate with the backend system and with your mobile app as well. So there will be some communication module as well. So it's called a smart meter. There are different communication technology we'll find like RF mesh, radio frequency mesh, radio frequency P2P, LTE category 1, NB-IoT. So there are many advantages if we adopt the NB-IoT technology, and especially the cost and the reliability, right? So reliability is very high. You will see about 97% success rate. So this is how the complete system would be. Consumer mobile app would be there, single phase, three phase meter, communication network would be there. There will be some head-end system which is collecting the data. Then there will be some meter data management system which is managing those data and giving this data to the utility CRM system. So this is how the complete solution will work. These are some pics of these single phase and three phase meter. So this meter comes with the Bluetooth connectivity as well. So if you recharge your system, the token can be transferred using the Bluetooth connection as well. So these are, there would be some vending system as well for utility people. Tariff design facility, because time of use tariff will be there and utility will start implementing those tariff very soon. So tariff change has to be very quick and without manual intervention. So with this solution on the air, the tariff can be programmed inside the meter. And this is the consumer mobile app by which consumer can take actions, and it's a very secure app with the authentication of OTP and those things. Temper management has to be there, definitely. Peak load management is available. Billing and collection efficiency will be improved. So this was about smart meter, how it will help in getting the energy security, right? So these are our smart metering experience. We have got 25 lakh meter order from North Bihar, and we have about 3 lakh meter installed so far there, and we are about achieving efficiency of 97% there. We have, as I said, we have smart metering experience since 90s. So in 1999, we have introduced first smart meter in Northern Ireland. Then UK, we have about 77 lakh meters we have introduced. Australia, we have about 1.5 million meters. Singapore, Malaysia, and in UK, what happened was there was a award for the smart meter data management, and Secure has got those award in 2015. Because we were the few of the company were there who were having everything in the solution, like electricity meter, gas meter, in-home display unit, head-end system, end-to-end system, and the integration with the utility system. So that was about smart meter. Now we are talking about achieving the climate goal by reducing the energy consumption. So there was a famous saying from Mr. Lord Kelvin that to measure is to know. If you cannot measure it, you cannot improve it. And everyone has its own definition as far as energy efficiency is concerned. Someone say that it's tail of elephant. Someone say it's a trunk of elephant. But everything is true. So what is energy efficiency? So how effectively energy is being used, how efficiently energy is converted, and method of using the energy translation. So there is a solution for smart thermostat. So this is a solution for split AC and FCU units. So there are many challenges, like if you go inside your room in your home, you immediately set the temperature using your remote, let's say 24 degree, 23 degree. But there is no any rationale why you have changed this temperature to 24, 23 degree, right? But at the same time, you can see the outside temperature, the temperature inside your room actually depends on the weather condition as well, right? So weather condition in the complete day, it actually used to happen in a bell curve. So there is a peak temperature, you need a peak load at 2 to 3 p.m. and peak cooling would be required in this peak load duration. So the flat set temperature will not work, and we need a cooling automation in this particular domain. So there are multiple parameters which defines how comfortable you are feeling, right? If I am wearing a coat, I am not feeling comfortable, but if you are wearing a simple, let's say, trousers and let's say in a night uniform, then you will feel, yeah, I'm comfortable. So it depends on your clothing as well. So there are many factors which decides your comfort level, right? So there should be some sort of solution which works on the cooling automation. So it depends, as I said, climate condition. If it's summer and if I change temperature to 20 degree, I'm feeling comfortable. But if it's winter with 30 degree, maybe I will not feel comfortable, I will feel cold. So it depends on climate change. Setting temperature is again a problem because you are changing the temperature. For example, at night time, you change the temperature to 22 degree. But at midnight, you will feel cold, but you will not get up and change the temperature. So it's again a problem. So flattened temperature will not work, right? And changes in the number of occupancy. For example, if this hall is full, you might be feeling, let's say, temperature higher. So there should be some solution which takes automatic decision. So this is a solution which takes automatic decision, and it will not give you the temperature flatten setting. It will give you the comfort. It will give you the option for the mode. Whether you need a comfort mode, whether you need a cool mode, very cool mode, warm mode. So it depends on the mode. So according to the mode, it will see what is the behavior of your user, right? So at different temperature and humidity condition, it will automatically change the temperature value. And we know that even a 1 degree temperature change in your air conditioner cooling, it will save you about 4 to 5% of your energy, right? So it is extra cooling which is wasted if you are not, focusing on this. And nowadays people are using AC. Everyone is using air conditions to have the comfort. So overcooling is a wastage, and time and budget is not there. So if you are talking about let's say big hospitals or big hotels, then it's a very big challenge to them, right? So they need a dashboard where they can sit and change the temperature and the other parameters from sitting at their desktop. And when the DG is operating, for example, if the DG is operating, the solution should be in the economical mode. So mobile app will be given. With this mobile app, user can select their mode, and the control operation would be from the mobile app, the web console. So the unit would be like something like this. If you can see, this is modes. So there is no any temperature setting. So user has to change the mode only, on which mode they want to start the cooling. So this will help in saving a lot of money. And this is for the FCU thermostat, which will be used in the hospitals or hotel industries. So this will be devices which will be connected with the internet through your router, and there will be a web console will be available on the cloud. So this would be something like this. The web console would be something like this, where you can see each of the device and you can control each of the devices. And you can even see the trend of your cooling, like temperature and humidity trend you can see for each device, and you can analyze for predictive maintenance and the energy saving. So this is again a case study about hospital. In an hospital, we have installed this device. 280 devices were installed, and after installing, what we have seen is with 24 degree flat, the valve off time was 4 hours, but with this logic, valve off time was 10 hours. So this was the saving in energy. So about 2.1 million INR they have saved. There is another solution called cloud-based energy management system. So again, this is for the industries. Here also the meters will be connected to the cloud, and the data will be seen at the mobile app and the web console. There is again a case study about Kanpur FMCG, where they have installed this meter, And what we have seen is this meter was having the harmonic parameter as well. And after installation, what we have seen is the voltage profile was not correct. The voltage was higher than the nominal value, which was actually impacting their performance. Power factor was not in control. The current unbalance was there. So they have made some changes in the transformer tap position, and they have made some changes to correct the unbalanced current. And by this, they have reduced about 10% of your annual consumption, and 2.3 lakh rupees was saved. So this is how the solution can help. So this is the mobile app and the web console screens. Now I will ask my colleague to present the energy consumption scenario for the water efficiency solution. So these are the facts about the water efficiency, like water pump. Any energy is intensive processes and have about 8 to 10% improvement scope. And energy losses are associated with pumps up to 50%, and wire to water efficiency can be reduced to 10%. Yeah.
Thank you, Kamal. So this is the one of the product of secure meter, Sensio. Sensio is a system which measure and monitor the pump performance. And this is basically how it helps in energy conservation. It is demand management system. We can do the energy conservation in pumps. So basically problems right now in pump operation is that we don't know the pump performance parameter, individual pump performance parameter. We don't know the station efficiency, we don't know the pump efficiency, we don't know the individual pump flow rate, head. What we know is that total flow rate of the pumping station, total energy consumption. So this is very limited parameters. We cannot take the decision based on this parameter for energy conservation. So which pump we need to take for refurbishment, what we need to do in the pump so that we can achieve the overall energy efficiency. So we cannot fine tune our operation. So this is one of the real data collected by the Sensio meter. These blue dots are actual performance data of one of the pump. You can see that flow rate is varying from 800 liter per second to 1300 liter per second. And this is efficiency curve. The orange curve is manufacturer curve. So manufacturer's best efficiency is around 83%. And what we achieve is, what we measure is 73%, 73% best efficiency. And this is around 10 to 12% drop in efficiency. So if we know this kind of the parameters, and the more problem is when the pumps was operated at 800 liter per second, the efficiency is around 60%. So that gap is more when pump was operated around 800 liter per second. So this kind of the data we required when we want to take the decision for energy conservation. A pump can be operated at 50% efficiency, same pump can be operated at 80% efficiency. With good health, good pump, then also we can operate that pump at 60% efficiency also. Because pump can be operated at best efficiency, but can be operated at left side of the best efficiency, right side of the best efficiency. Depending upon that, our decision should be for refurbishment or change or modification in the pump should be like that, so that we can achieve the maximum energy conservation. For that, we need the data. So this kind of data is required. The technology behind the Sensio is a very unique technology. So basically, right now, how we are measuring pump efficiency right now. So we measure flow rate, we measure suction pressure, discharge pressure by pressure gauge. We measure power meter, with the help of power meter, and put all this in an equation of energy efficiency. In that also we measure the pump we estimate the motor efficiency, and by that we calculate the pump efficiency. There is no system, or there is no meter which is available which measure all this parameter and tell you that this is the efficiency of the pump. In this scenario, this manual intervention is that is the one of the disadvantage. Another disadvantage is that the flow rate. It is very difficult to measure the individual flow rate. Individual flow rate of the pump is very difficult because we generally do not get the clear distance to install a flow meter. So we can measure the total flow rate in whole station flow rate, but we cannot measure the individual pump flow rate. Generally, in one station, we have 5, 4, even 10 pumps. So we can have total flow rate, but we cannot have an individual flow rate. Sometimes we get by installing an ultrasonic flow meter, but it may be accurate, it may not be accurate. It depends upon the site condition. So this is the disadvantage of this technology that is present right now we are using. Now what we are doing in sensiometer is that we, instead of measuring flow, we measure losses. So this losses is all the hydraulic losses in the pump, that is because of disc friction, because of internal circulation. All the hydraulic losses are converted into heat energy, and that heat energy we can measure in terms of the temperature difference. So there is a difference between discharge water temperature and suction water temperature. So that difference is very small, millikelvin. That is the technology. So if you cannot sense that differential temperature by normal thermometer or normal temperature sensor, especially the temperature sensors are developed for that, and that is being used to measure the suction and differential temperature across the pump. So we, as shown in this figure, we insert temperature sensor into the pipe at suction side and delivery side. We install a T-fitting, and from that tapping we measure the pressure also. So basically we measure losses, head and energy input. So there are 5 parameters we are measuring: suction temperature, discharge temperature, suction pressure, discharge pressure, and power meter. So with the help of these 5 parameters, we directly calculate the pump efficiency, and from that pump efficiency formula, same formula, we get flow rate. So flow rate is the final parameter that we get. So this is the unique technology. In this technology, we do not require straight pipe length without any obstacle. So we can install this temperature sensor and pressure sensor at the reducer. We can install a band also, but we cannot install flow meter near band, near reducer, near T-fitting, near valve, near NRV. But this is the problem in the current conventional method, that we can see that in this method we do not have this kind of constraint. And this one sensor system is you can install for one pump. If you have a number of pumps, you can install number of sensor. You can connect sensor and connect that sensor to modem, and that whole network, every sensor data can be connected to the server, cloud-based server, and we can get this data: which pump is running in the station, which pump is running at what efficiency, what is the flow rate of that pump, what is the head of that pump. That everything we can get on web-based solution or mobile app. So this is the configuration of web-based monitoring system. This is the first figure at top. On the top shows one of the dashboard of web-based solution. Here we can track the 7 days pump efficiency, 7 days volume from the station, total volume, daily volume, which pump is running right now, which pump is not running. So this kind of the everything data is available remotely. So normally water pumping stations are located remotely. So you can supervise all these things by web-based monitoring or mobile-based app. These three figures are of mobile app. Same data is available in mobile app also. So in the very first slide we have discussed about the problems, and that is here in this slide this is the solution. So we can measure number of parameters. These are some parameters, importance parameters I have mentioned here. There are more than 20 parameters of one pump and one motor can be available. And if you want to measure vibration of the pump, then also additional input or additional sensor can be connected to the sensor. So other than this parameter, these are the pump performance parameter, but conditioning monitoring parameters can be measured through this system also. So benefits of the sensor solution. So as discussed, I would like to summarize in that few lines that we can measure individual pump performance, that is pump flow rate, pump efficiency, pump head, pump power, all four parameters, main parameters. Other than that, we can measure the ampere, voltage and everything, suction pressure, discharge pressure, everything we can measure. So this parameter, main four parameters can be measured at individual level, and that can be monitored at 15-minute intervals. You can collect the monthly, yearly data, day-wise data. You can observe the operating regime. See, sometimes pump is operating at 800 liter per second, sometimes 1300 liter per second. Which one is better? So you can control or you can manage or you can fine-tune your operation so that you can maximize your efficiency. So this is the major advantage over other than this advantage, accuracy of flow and efficiency is less than 2%. Inaccuracy in the flow and efficiency is less than 2%. And the differential temperature, as I already mentioned, that is specially developed by the secure meter temperature sensor. This differential temperature can be measured up to 2 millikelvin. 2 millikelvin, 0.02 degrees Celsius or 0.02 Kelvin. So this is differential, that is why degree Celsius and Kelvin both are same.
So this is the patented technology from Secure, and you will not find anywhere in industry. And this was actually designed in collaboration with our UK design engineers, and especially this has been deployed for the municipal corporation and industries where we are finding higher rated pumps. Right? They will get much advantages with the help of this. Yeah.
So I will share two case study in next 5 minutes. We have a ESCO model, ESCO in Mansiwaka, Udaipur and Bhopal. ESCO model is that like that. We invest, we take the pumping station operation maintenance for 5 years, 7 years, whatever may be the trend, 10 years, and from that whatever operational cost, maintenance cost and everything to operate that pumping station we will do at our cost. To improve the pump, that also we will do at our cost. If required, we replace new pump, we require some parts to be replaced, then also we will do. On that basis, we have these two case studies. This is the Mansiwaka case study, Udaipur. Here we have and just 2 minutes. In this, we have operation maintenance contract also. So we are operating dam, we are maintaining dam, we are maintaining the civil structure of the pumping station, garden, we are maintaining motor, we are maintaining capacitor bank, everything as per the contract. We have installed our sensor system there cloud-based system. We get that data, we analyze that data, and from that we have taken the refurbishment activity. We have planned, and then we got the energy savings. As talked, we have done capacitor, we have improved capacitor bank also, and we have improved power factor also. So this is the result. Pump efficiency is improved from 67% to around 80%. This is 13 to 14% improvement, and still it is operating. It has been improved 5 years back, and still these pumps are operating at the same level. However, there is some 1 or 2% deterioration, but these pumps are operating with around this 78-79% efficiency right now. So this is the cost of production, water production. So when baseline was done, it was 4.14 per KL, rupees per KL. And right now it is 3.66 rupees per KL. This is energy cost. This is 11.6% improvement. Similarly in Bhopal, this improvement is around 74% to 86%. 86% is the manufacturer efficiency that manufacturer claim. And this is the result we achieved during the baseline. The energy cost is 2.10 rupees per KL, and right now it is 1.89 rupees per KL. This is 10% improvement. So thank you.
Yeah. Thank you.
Any question? There are 2 minutes till the second speaker is ready. Any question you can ask till the second is ready.
Energy transition के energy transition particularly from the day-to-day life that we are living in. Please, I'll encourage energy transition के कुछ उदाहरण दीजिए. मेरे पास टोटल कितना वक्त है? 10 मिनट? कम है?
30 minutes.
बहुत ज़्यादा है. तो मर जाऊंगा इतने में, है ना? हाँ, तो प्लीज मेरे को एनर्जी ट्रांजिशन की कुछ मिसालें दें, मुझे अच्छा लगेगा. रूफटॉप सोलर, वंडरफुल. प्लीज ओपन अप. हाँ, वंडरफुल वंडरफुल. हम सोर साइड पे जा रहे हैं. वी आर मूविंग ऑन टू द सोर साइड, द जनरेशन पार्ट ऑफ इट. विंड, सोलर, न्यूक्लियर also. Let's come to the load side. Huh? These are all source side. These are all source side. These are all generational parts of it. Let's come to the load side, consumption side. How are we consuming that energy? In what forms are we consuming that energy? AC to DC. One example. One electrical engineer amongst us, wearing Hitachi T-shirt, wonderful, great man, young man, has told AC to DC. Yes. EV charging. Wonderful, wonderful, great. अरे घर में चक्की चलाती थी मम्मी, नानी, अब वो चक्की बन गई मिक्सी. Lights, AC. And since British left us, look at railways. Okay, look at railways. It was steam, big. अच्छा, उसके पहले जाते हैं. जब अंग्रेजों ने रेलवे स्टार्ट करी थी तो घोड़े लेके जाते थे. तो दैट वाज द डोंकी लेबर was the word. Donkey labor is the word still used in railway literature. तो donkey labor was used. फिर donkey labor के बाद horse powers. There were, let's say, 2000 horses drawing your cart and you were enjoying. Thereafter came that steam engine. You know, the innovators and inventors of steam engine. Thereafter came diesel engines. Steam engines was the time when the world only had engineers, no civil, electrical, mechanical. Steam engine मतलब engineer, one who made the building, one who designed it, one to operate, only engineer. ठीक है. Thereafter we moved to steam. Thereafter we moved to diesel. That was the mechanical engineers. Diesel engine, so wonderful a word. Thereafter came, हाँ? Yes. तो मैं वो वर्ड आपसे सुनना चाह रहा था और इन्होंने साहब ने अच्छा वर्ड बोला. Engines were replaced by motors. Engines were replaced by motors. Now, what are we heading to? What are we heading to? हाँ, अभी तो इलेक्ट्रिक ट्रेन है ना, आप जाते हैं तो इलेक्ट्रिक ट्रेन से ही जाते हैं. We are moving on to hydrogen trains. We are moving on to even cleaner motives. So these are examples of energy transition. और मैं आपसे दरखास्त करूंगा that as a responsible citizen of this country, we need to consciously look at how our energy consumption patterns are changing. Okay? Why? The question comes why? क्या आज इस देश को ये पता है कि उसकी एनर्जी डिमांड कितनी है? हम ये तो कहते हैं आई एम मूविंग ऑन टू एनर्जी सिक्योरिटी. One you cannot measure. Just now we saw on the slide Lord Kelvin. One you cannot measure, you cannot control, you cannot monitor. So कुछ नहीं होगा उससे. हमें पता ही नहीं है. क्यों नहीं पता है? जब मेरे घर बत्ती आ गई तो मैं जो कुछ लगा सकता था लगा दिया और वो बढ़ता गया.
किसी चीज की इंपॉर्टेंस ही नहीं.
हमें कॉन्शियसली रियलाइज करना है हाउ आवर एनर्जी कंजम्पशन पैटर्न्स आर चेंजिंग. How are we changing our energy consumption patterns? I hope all of us love to travel with railways. Of course, उसके bitter experiences भी होते हैं, अच्छे experiences भी होते हैं, मोहब्बत भी होती है, पॉटी खराब भी होती है. But मैं आप सभी से आज ये रिक्वेस्ट कर रहा हूं कि आपसे भी, आप हमारे इंडस्ट्री पार्टनर्स हैं, हमको एक सॉल्यूशन प्रपोज कीजिए. अभी हम इस रूम में उसको फाइंड आउट करना चाहते हैं. रेलवे वाले अपने एसी का तापमान कैसे रेगुलेट करें? लेट्स हैव दिस. इट्स अ बिग इंडस्ट्री प्रॉब्लम. इट्स अ बिग प्रॉब्लम वी आर फेसिंग. ऑलराइट, क्या कर सकते हैं? सरकार ने, लाइक ब्यूरोक्रेसी वर्क्स, सरकार ने निकाल दिया 24 डिग्री रखना है. समर्स में 24, विंटर्स में 26 या 28 है. फाइन. अब वो बंदा चेंज करता है. किसी को ठंड लगती है, किसी का बच्चा बीमार है. लाइक दैट. इट्स अ बिग प्रॉब्लम वी आर फेसिंग एंड वी नीड नॉट ओनली इंडस्ट्री बेस्ड सॉल्यूशंस, वी ऑल्सो नीड ह्यूमैनिटेरियन सॉल्यूशंस. मैं टॉपिक से डेविएट नहीं होऊंगा, लेकिन what do I mean by humanitarian solutions, ladies and gentlemen? By humanitarian solutions, we mean to say, अगर मैं रेलवे से जाना चूज कर रहा हूं by choice, so I am choosing to make a community travel. If I am choosing to travel by airlines, I am choosing to make a community travel. All right. If I am traveling by my own car, I am choosing to travel privately. मैं अपने हिसाब से एसी, अपने हिसाब से म्यूजिक एडजस्ट कर सकता हूँ. बट व्हेन आई एम मूविंग इन अ कम्युनिटी, somebody has to adjust, then only the community can survive. All right, we have to, the message I want to give in each one of us is, we have to very consciously look at our energy consumption patterns, and we will realize that not only we are moving from, this is making a big churn. हम एनर्जी कंजम्पशन पैटर्न्स कितने खतरनाक लेवल पे बढ़ाते चले जा रहे हैं. सेकेंड क्वेश्चन इज, व्हाट डू वी मीन बाय एनर्जी सिक्योरिटी? लेडीज एंड जेंटलमैन, प्लीज, वी विल पार्टिसिपेट फ्रॉम दिस साइड ऑल्सो. व्हाट डू वी मीन बाय एनर्जी सिक्योरिटी? एनर्जी ट्रांजिशन की कुछ मिसालें हमने देखी. मैडम प्लीज.
Sustainable solution of energy, like generation, the coming generation should be able to use that particular energy source.
Wonderful. So sustainability comes in. This young beautiful woman has just talked about sustainability. Yeah, please. Energy security, I said.
We have to stop energy theft.
Okay, good. Energy theft is to be stopped. Yes.
No blackout.
No blackout. Wonderful. Grid stability to that extent. No blackout.
Supply and demand has to be balanced.
I take your word, but demand can only be balanced by generation once we know our demand. The demand is exponentially rising. Of course, which is the symptom of a developing country, by the way. जैसे आपके रेट्स ऑफ इंटरेस्ट फ्लक्चुएट करते हैं, जैसे इन्फ्लेशन फ्लक्चुएट करता है, वैसे एनर्जी डिमांड ऑफ अ डेवलपिंग कंट्री विल राइज. It will come to a saturation or a threshold once we have developed, once the industry has pulled up, once the demand. बहुत सारी ट्रेनें और चलानी है, बहुत सारी फ्लाइट्स और चलानी है, बहुत सारी हमारी पॉपुलेशन बढ़ रही है, तो ऑफ कोर्स दैट विल हैपन. गुड आइडिया. और व्हाट एल्स?
Accessible to all.
हाँ, क्या बात है, क्या बात है. यस, एक्सेसिबिलिटी. यस, प्लीज कम अप. एनर्जी सिक्योरिटी. व्हाट डू वी मीन बाय एनर्जी सिक्योरिटी?
Withstand any contingency.
Withstand any contingency, we must have a backup. Wonderful. Okay, we have got lovely audience here, and the availability, the accessibility and affordability of energy is energy security. Okay, ladies and gentlemen, I repeat, the availability, the affordability and accessibility of energy is energy security. Okay, let's take some examples. मैं आपको बत्ती 18 रुपए यूनिट दूंगा. अवेलेबल तो है, एक्सेसिबल तो है, अफोर्डेबल नहीं है, आप खरीदेंगे ही नहीं. दिस इज व्हाट हैपेंड विद न्यूक्लियर पावर जनरेशन इन इंडिया. दिस इज व्हाट एग्जैक्टली हैपेंड. 10 साल पहले सोलर जनरेशन, सोलर रूफटॉप जनरेशन वाज हैविंग दिस प्रॉब्लम. वी हैव अवेलेबिलिटी ऑफ सोलर पावर, we have accessibility of solar power, but we do not have the affordability. Ladies and gentlemen, the entire idea of human existence is about affordability. I am indeed delighted कि हमारे पास अब ऐसी टेक्नोलॉजीज हैं, हमारे पास ऐसे सॉल्यूशंस हैं, हमारी सरकारें इतना इन्वेस्ट कर रही हैं, लोग आर विलिंग कि हम सोलर रूफटॉप लगा करके एनर्जी को प्रिजर्व कर रहे हैं, एनर्जी को बचा रहे हैं, एनर्जी को अपने यूटिलाइजेशन में यूज़ कर रहे हैं. मैं बोर करने लगूं तो प्लीज़ बताइएगा, बहुत देर तक बोर करना अच्छा नहीं है. तो दीज 3 पैरामीटर्स वी हैव टू लुक आफ्टर. अब जैसे मैं आपसे, वी आर ऑल इंजीनियर्स, आप प्लीज़ कंट्रीब्यूट कीजिएगा. जैसे अभी हमने ये कहा 1 डिग्री एसी का तापमान बढ़ाने से 5 से 6% एनर्जी सेविंग होती है. ओके, वंडरफुल, ग्रेट आइडिया. मैं बस ये पूछ रहा हूं आपसे कि जो एसी में 23 डिग्री होता है, ये कहां का तापमान होता है? अरे हाँ, आइडिया आने दें. एसी का 23 डिग्री जो है वो कहां का तापमान है? एसी तो वहां लगा है, लेट से वहां लगा है. अब वो इस कॉर्नर के मतलब इज दिस ऑफ दिस कॉर्नर? हाँ, रूम टेम्परेचर. अब रूम में तो बहुत सारे लोग हैं. एक भाई साहब आए, गर्मी से, धूप में से आए और आ गए, कमरे में बैठ गए, तो वो तो गर्म है. अच्छा, फिर अगर रूम का टेम्परेचर है मान लेते हैं, तो उसका सेंसर कहाँ है? सेंसर के लिए तो दीवार तोड़ी नहीं, उसने तो लगाने के लिए तोड़ी थी. सेंसर तो नहीं तोड़ी, तो सेंसर कहाँ है? एयर कंडीशनर के अंदर है. ओके, मान लिया आपकी बात. तो अब 23 डिग्री किसके लिए है और कहां है? ये प्रश्न एसी बनाने वालों को भी नहीं पता है. ये ऐसा प्रश्न है जो किसी को नहीं पता है कि मैं क्या, देखिए ना, सब लोग जानते हैं क्लोज लूप कंट्रोल सिस्टम, एक चीज सेंस करेंगे उससे ऑटोमेटिकली वो एरर एंड यू नो द आउटपुट चेंजेस. We have to consciously consume our energy like we consciously consume our food. We have to consciously consume our energy. हम
But public is to be educated about it.
100%. I agree with you. I agree with you.
We are amending the technology, upgrading this, but public is not understanding the thing. That is the main thing behind this.
Wonderful. Great ideas.
Dual inverter, 5-star AC doesn't reduce the
Yeah, of course.
consumption.
Of course.
मैं वही आपसे कह रहा हूं कि आप कंजम्पशन का क्या मतलब है. क्या मैं पहले ऑल्टो 800 चलाता था लेट्स से, या मारुति 800, और पीछे आप लोग और पुरानी कोई गाड़ी बताएंगे, फिएट वगैरह, तो हाँ, तो मैं फॉर एग्जांपल ऑल्टो 800 या मारुति 800 चलाता था. लेट्स से द एफिशिएंसी ऑफ दैट व्हीकल वाज, ऑफ दैट ऑटोमोबाइल वाज, कितनी रख दूं मैकेनिकल इंजीनियर साहब, 60%. इंजन है, 60% एफिशिएंसी मारुति 800 की, 60 ना चल जाएगी, 40 थर्मल पावर प्लांट की होती है यार, 40 तो वो तो घिस घिस के चलता है. लेट्स से 50%. अभी हमने सॉल्यूशंस निकाले और एफिशिएंसी कर दी 80%. लेट्स से एज्यूम करते हैं 80% एनर्जी एफिशिएंसी है, ईवी है मेरे पास, इलेक्ट्रिक व्हीकल है, मोटर ड्रिवन व्हीकल है, बट मैं लेके चल रहा हूं, पहले मेरा कंजम्पशन था 800 सीसी, ऑल्टो 800 का मतलब 800 सीसी का इंजन है उसमें, अब मैं यूज कर रहा हूं 3000 सीसी, और थ्रो नहीं मिल रहा, एक्सीलरेट नहीं कर रहा, वो भी एक पे एक. 100% I agree with what sir has just now mentioned and pointed out, that most of our problems are not infrastructural problems alone. Many of our problems are community and society problems, societal problems. We need to very consciously consume our energy and look after how are we consuming, generating and misutilizing या rather utilizing our energies. All right? और ये मैं इंसान की मानवीय एनर्जीज के साथ साथ इलेक्ट्रिकल और मैकेनिकल और कंप्यूटर एनर्जीज के बारे में भी कहना चाहता हूँ. ठीक है, सो वी टॉक्ड अबाउट एनर्जी ट्रांजिशन स्लाइटली, वी टॉक्ड अबाउट एनर्जी सिक्योरिटी स्लाइटली. आई जस्ट टच अपॉन हाउ रेलवेज वर्क्स. इट्स एन इंटरेस्टिंग मॉडल. इट्स ऐसा मॉडल है जो पूरे देश में चलता है, पूरी दुनिया में चलता है. तो एक दफ़ा मैं द रोमांस ऑफ रेलवेज जो है वो आप लोगों के साथ शेयर करना चाहता हूँ. आप मोबाइल में देखते हैं तो मुझे अच्छा नहीं लगता, तो मेरी आंखों में देखेंगे मुझे अच्छा लगेगा. थैंक यू. तो मैं क्या कह रहा था, द रोमांस ऑफ रेलवेज, हाउ वी प्रोड्यूस पावर, हाउ वी कंडीशन इट. अभी मैंने एक और वर्ड बोला, कंडीशनिंग ऑफ पावर. How we condition it, and thereafter how we utilize it, या rather how we misutilize it, both ways. Generators still, first of all, most of 80 to 85% of the power that Indian Railway uses is thermal power. अभी renewables उतना कंट्रीब्यूट नहीं कर पाए हैं कि हम, अच्छा मैं आपको और इंफॉर्मेशंस रिवील करने से पहले ये बताता हूँ कि गुजरात की एंटायर इलेक्ट्रिसिटी फॉर रेलवे कंजम्पशन इज परचेज इन वडोदरा, बिकॉज वी हैव स्टेट लोड डिस्पैच सेंटर इन वडोदरा. आई परचेज एवरी डे 170 megawatts ऑफ पावर फॉर इंडियन रेलवे. व्हाट डू आई मीन बाय परचेज? मैं इस पे आना चाहता था. व्हाट डू आई मीन बाय आई परचेज? What do I mean by I purchase? I'll just elaborate on this. Purchase का क्या मतलब है? हमारे घर में बिजली आती है, एक मीटर लगा है जिसको खोलने की मनाही है ना, और वो मीटर महीने के एंड में बिल रीड करता है, और कुछ जो सॉल्यूशंस बताए कि वो ऑनलाइन ऑफलाइन वो सब से होके मेरे को प्रीपेड या पोस्टपेड पेमेंट करना पड़ता है. मेरे को तो 7 रुपये यूनिट पड़ती है, मैं बढ़िया यूज करता हूं, 10,000 का बिल आता है, बात खत्म। बल्क पावर्स आर नॉट परचेज लाइक दैट। जो आपको प्रोवाइड कर रहा है टॉरेंट पावर या मे बी जो भी ऑपरेटर्स होंगे, आई डोंट नो द नेम्स, रिलायंस पावर, यहां पर जो ऑपरेटर्स होंगे मेरे को नहीं पता है, वो खरीद करके बल्क पावर ट्रेडिंग करते हैं और आपको प्रोवाइड करते हैं। ओके, आज आप लोगों की जानकारी के लिए मैं ये भी बता देता हूं, इंडिया में एक रजीम है जिसका नाम है ओपन एक्सेस, और एक्चुअली तो जीएनए और आ गया है, जनरल नेटवर्क एक्सेस, बट लेट्स ओपन एक्सेस क्या मतलब है। अभी एक जनाब ने फरमाया कि द ग्रिड मस्ट बी स्टेबल, ग्रिड इनर्शिया की अभी बात हो रही थी। इसका क्या मतलब है? जितने ज्यादा जनरेटर्स मेरे ग्रिड में अवेलेबल होंगे उतना उस ग्रिड को डिस्टर्ब करना कठिन होगा। डिस्टर्ब का क्या मतलब है? मैडम का मन आया, मैडम ने इलेक्ट्रिक व्हीकल लगा दिया, पता चला बत्ती बैठ गई, मजा नहीं आएगा। ग्रिड इज वेरी अनस्टेबल। और हमने अपने सारे दुनिया के एसी लोड लगा दिए, बट स्टिल ग्रिड सस्टेन्स इट, ग्रिड इज स्टेबल, राइट? जितने जनरेटर्स, तो ये प्लान करा गया, लेट्स हैव ए नेशनल ग्रिड जिसमें दुनिया के, इंडिया के सारे जनरेटर्स और सारे लोड्स एक साथ आ जाओ, सब आ जाओ, ओके? और फिर आपको जितनी बत्ती चाहिए आप भैया बताओ, और आप किस रेट पे खरीदना चाहोगे वो बताओ, आप जिस रेट पे बेचना चाहोगे वो बताओ। तो लेट्स हैव ए नेशनल इंडियन इलेक्ट्रिसिटी एक्सचेंज जिसमें ऑल पीपल कम, ओके? एंड देयर आफ्टर बल्क यूजर्स लाइक रेलवेज, लाइक योर टॉरेंट पावर्स, एंड एवरीबडी परचेजेस पावर, और फिर वो पावर आपको खरीद करके देता है। इस तरीके से हम पहले रेलवेज एज ए यूनिट पावर को खरीदते हैं, उसको गिवन वोल्टेजेस पे, गिवन फ्रीक्वेंसीज पे, गिवन वोल्टेज क्वालिटी पे, पावर क्वालिटी पे कंडीशन करते हैं इन आवर ट्रैक्शन सबस्टेशंस एंड अदरवाइज, और उसके बाद उसे डिस्ट्रीब्यूट करते हैं। मेरा काम वहीं से चालू होता है। मैं 25 केवी का आदमी हूं मिनिमम, है ना? तो माय वर्क स्टार्ट्स एट 132 केवी मिनिमम एंड एंड्स एट जहां तक ट्रेन जाती है, गोधरा तक जाती है बड़ौदा की ट्रेन, ऑलराइट? ये मैंने आपको एक प्रोसीजर बताया। दिस इज हाउ वी जनरेट एंड कंज्यूम आवर पावर। उसी बत्ती से एसी चलते हैं, उसी बत्ती से आप अपना मोबाइल चार्ज करते हैं, वही बत्ती डिस्ट्रीब्यूट होती है, वही उसकी प्रोसेसिंग होती है, एसी टू डीसी एंड मैनी 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 स्टेजेस। अब मैं आपको इमेजिन करवा रहा हूं, विजुअलाइज करवा रहा हूं कि कोयले से लेके आपके मोबाइल के चार्ज तक कितनी स्टेजेस आई और उसमें कहां कहां लॉस हुआ। देन आई विल कम टू द कंक्लूजन, कम टू द पॉइंट, व्हाई एम आई मेकिंग दैट पॉइंट। ऑलराइट, लेट्स हैव, पहले कोयला कहां गया? कोयला निकला कहीं से, कहां से निकला? किसी माइन से कोयला निकला, उसकी धुलाई पुछाई हुई, धुल गया, पुछ गया, ट्रांसपोर्ट हो। एज्यूम करते हैं कि जनरली थर्मल पावर प्लांट्स आर लोकेटेड एट कोल हेड, कोल के मुंह पे लगाते हैं उसे, बिकॉज ट्रांसमिशन ऑफ इलेक्ट्रिसिटी इज चीपर देन ट्रांसपोर्टेशन ऑफ कोल। तो कोल हेड पे मैंने पावर प्लांट लगा दिया। इंडिया में जो टेक्नोलॉजी अवेलेबल है, जब तक एटलीस्ट मैं रेलवे में आया तब तक, तो उसकी मैक्सिमम एफिशिएंसी 40, 50, 55% थर्मल जनरेशन की एफिशिएंसी है, ओके? तो अब मैं आपको एक एनर्जी स्टैटिस्टिक्स दूंगा। मेरे पास बहुत स्लाइड्स नहीं है, वक्त नहीं था, मैं नहीं बना पाया, माफ कीजिएगा, पर मैं एक एनर्जी स्टैटिस्टिक्स आपको विजुअलाइज कराऊंगा कि ये टेबल कैसे छोटी होती जाएगी, ओके? लेट्स से एनटीपीसी ने 100 मेगावाट ऑफ कोल बर्न करा, पहले खरीदा फिर बर्न करा, राइट? अब मैंने जो एफिशिएंसी बताई, लेट्स एज्यूम 50%, वहां पे 50 मेगावाट तो आसमान में गई और 50 मेगावाट एनटीपीसी ने पावर ग्रिड को दे दी। एटलीस्ट पावर ग्रिड ने सब कुछ करके 10% लॉसेज इनकर करे। 50 का 10% ग्रिड में गया, 45 मेगावाट बची। ओके 45 मेगावाट के बाद रेलवे के ट्रैक्शन सबस्टेशन में आई, थोड़ी तो मैं भी खाऊंगा, तो 10% एनर्जी मेरी प्रोसेसिंग में लेट्स अज्यूम गई, 45 का 10% और गई, कितनी बची? लगभग 40। ओके इसके बाद जो लोकोमोटिव था, जो पूरी ट्रेन को फीड कर रहा था, वहां एक ट्रांसफार्मर और एसी डीसी कन्वर्टर था, एसी से डीसी बनी। ऑलराइट, बहुत एफिशिएंसी अच्छी है, पावर इलेक्ट्रॉनिक्स इंजीनियर्स हैं, 90% एफिशिएंसी थी, 10% लॉस वहां भी था, 36 मेगावाट रह गई, 36 मेगावाट रह गई, है ना मैम? आप मेरे साथ हैं? आप सोई तो नहीं ना? ओके कोई नहीं सोया ना?
नहीं
36 मेगावाट रह गई। 36 मेगावाट के बाद ये ट्रेन के अंदर डिस्ट्रीब्यूट हुई, बटी ना, लोकोमोटिव तक तो आई थी, अभी तो बटी, एक कोच से दूसरे कोच, दूसरे से तीसरे कोच, बटी। लेट्स से 95% एफिशिएंसी थी, 5% लॉस हुआ, 35 मेगावाट रह गई, 36 की 35 हो गई, ज्यादा नहीं होगी डिस्ट्रीब्यूशन में। फिर आपने लगाया अपना चार्जर, भाई साहब चार्जर इज अनदर डीसी टू एसी टू डीसी है एक्चुअली, लेकिन वो इतना अच्छी है, उसके आगे जेनर डायोड वगैरह लगा दिए हैं कि वो डीसी टू डीसी भी चल जाता है। तो 110 वोल्ट डीसी पे जब मैंने चार्जर लगाया, एस्यूमिंग उसकी भी एफिशिएंसी 90% थी, बहुत अच्छा चार्जर होगा एप्पल का या सैमसंग का, तो ओरिजिनल चार्जर लगाया आपने, 90% एफिशिएंसी पे काम किया। 35 मेगावाट जो बचा था उसका 10% और खत्म हो गया, अराउंड 30 मेगावाट आपको मिला। लेडीज एंड जेंटलमैन, नाउ आई कम टू माय पॉइंट। एक आदमी जो वहां पे 100 मेगावाट एनर्जी इनपुट दे रहा है, वो चेयरमैन साहब को, जब चेयरमैन साहब राजधानी में ट्रैवल करके अपना मोबाइल चार्ज कर रहे हैं, तब उसका 1/3 से भी कम पार्ट मिल रहा है अवेलेबिलिटी के लिए। मैंने क्या बोला? अवेलेबिलिटी, अफोर्डेबिलिटी एंड एक्सेसिबिलिटी। ऑलराइट, ये एनर्जी मैट्रिक्स जो आपने जस्ट अभी देखी, 100 मेगावाट वाज जस्ट रिड्यूस्ड टू 30 मेगावाट व्हिच वाज अवेलेबल फॉर द एंड यूजर। अब आप मेरे को ये बताइए, अगर एंड यूजर 1 मेगावाट बचाता है तो वो कितने मेगावाट इक्विवेलेंट कोल बचाता है? ये मेरे को बस बताइए। 3 मेगावाट इक्विवेलेंट ऑफ कोल बचाता है। दैट इज द पॉइंट आई वांटेड टू मेक इन दिस। मैं केवल इसी को बताने आया हूं आज, बाकी बातें मेरे को करनी नहीं, आपसे कर लूंगा, ठीक है, दिल लग रहा है तो कर लूंगा। द पॉइंट आई वांटेड टू मेक, फर्स्ट पॉइंट इज वी हैव टू बी वेरी वेरी कॉन्शियस ऑफ व्हाट वी ईट इन आवर फूड एंड व्हाट वी कंज्यूम as energies. All right. Second point, if the consumer, if the end user of this country saves 1 megawatt, this nice fellow saves 3 megawatt of the national property, which is coal or whatever process you use. Are we clear? Are we enjoying this journey?
Yeah.
Wonderful. तो हम बत्ती बचाने के मेजर्स करेंगे, वो मैं लिख के लाया हूं कि हमें क्या करना है, वो मैं लिख के लाया। ऐसे ही मैं एक माइक्रोफोन लगेगा, ठीक है, आप मेरे को सुन पा रहे हैं? क्या हाँ, चल रहा है, हाँ, थैंक यू। तो मैं देख रहा था, जस्ट आई वॉज हैविंग अ व्यू ऑफ दिस लाइटिंग। आप लोग समझ गए जो मैं कहना चाहता था, ताली बजा दीजिए। ऐसी भी क्या नाराजगी है अभी है? तो पॉइंट आई वांटेड टू मेक इज, नंबर 1, प्लीज as a matter of your awareness and your consciousness। अच्छा, आप करेंगे क्या? मैं बार बार यही कह रहा हूं, why? Everything has to revolve around that why. Sorry, I am interrupting some audience. Everything has to revolve around that why. मैं जो करूंगा, किसी ने बोला था सस्टेनेबिलिटी, इन्होंने बोला था मैं जो करूंगा, धन संपत्ति तो ठीक है, ब्लैकआउट होंगे तो कैसे चलेगी दुनिया? If we do not have energy security, if we do not have food security, we cannot survive. और obviously हम पीछे नहीं जा सकते. अब हम उस रास्ते पे आ गए हैं that a small motor has to replace a bigger motor and that bigger motor will be replaced by probably a hydrogen engine or something else. अब हम पीछे नहीं जा सकते. अब हम वापस चक्की पे जाके चटनी नहीं पीसेंगे. We don't like it and we are not ready for it also. Therefore, I have come up with some घरेलू उपचार. मैं तो कहूंगा कि घरेलू उपचार ये है भैया कि ये घरेलू उपचार अपना लीजिए और आने वाली जनरेशन्स को एनर्जी सिक्योरिटी देके जाइए. पहला पॉइंट है, ऑल फिटिंग्स आर टू बी रिप्लेस्ड विथ एलईडी फिटिंग्स एंड इफ एट ऑल इन द प्रोसेस ऑफ एनर्जी ट्रांजिशन वी कम अक्रॉस अनदर बेटर टेक्नोलॉजी, लेट्स अडॉप्ट इट फास्टर. ओके, एलईडी इज नॉट द एंड, होगा ही नहीं ये, क्योंकि कोई आदमी दिमाग लगाएगा, वो इनकैंडेसेंट लैंप से एलईडी पे ले आया है, एलईडी से कुछ और पे लेके जाएगा, लेकर जाएगा. दैट जर्नी हैज बिगन. ऑलराइट, देयरफॉर फिर अब ये सेकंड पॉइंट बहुत इंपॉर्टेंट है फॉर पीपल हु आर रिजाइडिंग इन फ्लैट्स. मोस्ट ऑफ अस आर, हम सब कितने लोग फ्लैट में रहते हैं? क्या बात है, हम छोटे छोटे कंप्रेसर क्यों लगाएं? हम छोटा सा एक सोलर पावर प्लांट क्यों लगाएं? हम छोटा सा एक इलेक्ट्रिक गीजर क्यों लगाएं अपनी कन्वीनियंस के लिए? यहाँ तो गीजर की इतनी रिक्वायरमेंट नहीं है, वी आर इन अ हॉट बेल्ट, बट इन द नॉर्दर्न पार्ट्स ऑफ द कंट्री वी नीड. तो द सॉल्यूशन कम्स अगेन, आई एम जस्ट रीइटरेटिंग दोस 4-5 पॉइंट्स. मैं जो 4 पॉइंट लेकर के आया हूँ, मैं कुछ तैयारी करके नहीं आया हूँ. मेरे जो 4-5 पॉइंट हैं उसमें एक पॉइंट है कम्युनिटी बेस्ड सॉल्यूशंस. हम लोगों ने एडजस्ट करना बंद कर दिया. आपकी जनरेशन तो करती थी सर, हम लोगों ने एडजस्ट करना बंद कर दिया. हम शादी में जाते हैं तो रूम में बैठने के लिए जाते हैं हम, विच इज बैड. शादी में गए हैं तो ट्रेडिशनल शादी होनी चाहिए ना यार, सब एंजॉय करेंगे एक डॉर्मेट्री में फॉर अ कम्युनिटी सेलिब्रेशन, राइट? लाइक गरबा, विच आई लाइक, मेरे को बहुत पसंद आ गया है. मैं आई डू नॉट पर्टिकुलरली बिलोंग टू गुजरात बाय द वे, बट जिस तरह से यहाँ पे मेरे को लोगों ने गले लगाया है और मैंने गुजरात को गले लगाया, आई लाइक इट. ऑलराइट, रेलवे की नौकरी लेके आ गई, मुझे पसंद आ गया, इश्क हो गया, मैं जाना नहीं चाहता, है ना? एनी विच वे, कम्युनिटी सॉल्यूशंस हमें चाहिए, नॉट ओनली इन आवर फैमिली वैल्यूज एंड सोसाइटल वैल्यूज बट ऑल्सो इन आवर एनर्जी कंजम्पशन पैटर्न्स. ऑलराइट, तो बल्क कंप्रेसर, वाटर कूलर टू बी रिप्लेस्ड बाय वाटर डिस्पेंसर. ओके, हम विल कम, हाँ प्लीज.
वो अफोर्डेबल भी रहेगा.
हाँ, क्या बात है, एफोर्डेबल रहेगा, ऑफ कोर्स.
2 टन का एसी और 1 टन के एसी में सिर्फ 2000 का डिफरेंस ही रहता है, ऐसा अमाउंट नहीं है.
आपने बहुत अच्छी बात कही है. हॉस्टल्स में जाते थे ना, तो मेस का खाना लगता था कि बेकार तो है, ठीक है, होता है, ठीक है, लेकिन यार एक उसमें इकोनॉमी तो होती है. वो बना के एज अ कम्युनिटी सर्व करेगा आपको, तो वो खाना 100 रुपए प्लेट से ज्यादा नहीं पड़ेगा. एग्जैक्टली द पॉइंट आई वांटेड टू मेक. द 3 पॉइंट्स विच मैं एक बार टेक होम मैसेजेस जो होंगे वो मैं फाइनली कंक्लूड करूंगा. ठीक है, सोलर गीजर्स, प्लेटफॉर्म लाइटिंग तो मेरे लिए थी, ठीक है, डोंट गो फॉर इट, ये घरेलू सॉल्यूशंस में नहीं है. ऑडिटिंग होनी चाहिए वर्क सेंटर्स की, वी आर वेरी वेरी बैड एट इट. ओके, आप में से जितने लोग ये चीज करना चाहते हैं, सीखना चाहते हैं, इट इज फॉर एवरीबडी, ऑल टाइप्स ऑफ इंजीनियर्स एंड नॉन इंजीनियर्स ऑल्सो. दैट इज कॉल्ड एनर्जी ऑडिटिंग. लोग हैं जो, जैसे ये ऑडिटोरियम है, इसका एनर्जी ऑडिट करते हैं, जो डेफिशिएंसीज हैं, जैसा इन्होंने करके बताया वहाँ उदयपुर और आई थिंक भोपाल, राइट, उदयपुर और भोपाल में कि इतनी एफिशिएंसी से इतनी आ गई. इस तरह की एनर्जी ऑडिटिंग की जरूरत है. आप इमेजिन कीजिए कि एक बड़े जहाँ पे 100 फ्लैट हैं या 150 फ्लैट हैं, वहाँ एनर्जी ऑडिटिंग कितना हेल्प करेगी, है ना? फिर मैं जो पॉइंट लाल करके लाया था वो आपने पहले ही बता दिया. अब मैं क्या बताऊँ कि 1 डिग्री तापमान बढ़ाने पे 6 डिग्री सेविंग होती है. यूज एफिशिएंट दिस थिंग, बोलने की जरूरत नहीं है, आप सबको पता है. स्टार रेटिंग, सो किसी भी इक्विपमेंट में इंक्लूडिंग मोबाइल फोन, इन एनी इन्वेस्टमेंट देयर आर 2 कॉस्ट्स. वन इज द capital cost, the first cost, the purchase cost, and second initial cost, and second is the running or the operational cost. If we invest in star ratings of your equipment, BEE rated होते हैं, और what will happen is the installation cost will probably rise, but the maintenance cost and the operational cost will be low, given that you purchase from a trusted partner. All right. So, amongst various things which I have thought of today, एक आपने केस स्टडी कहा तो मुझे आइडिया मिल गया. तो एक मेरे मतलब हम लोग तो रेलवे कॉलोनी में रहते हैं, तो थोड़ी दूर पे एक लड़का है नीरव. ओके, वो मुझे वाकई बड़ा स्मार्ट लगा. उस आदमी ने, उस मनुष्य ने क्या काम करा, अपनी छत पे लगाई सोलर रूफटॉप पावर प्लांट, जिसका बड़ा जमाना है, और उसने खरीद लिया इलेक्ट्रिक व्हीकल. और ये आदमी फ्लैट में नहीं रहता, फॉर सम रीजन, रईस होंगे पापा, नहीं रहता. ये आदमी टेनामेंट बोलते हैं, क्या बोलते हैं यहाँ पर, हाँ, अपने घर में रहता है. मतलब सीधी बात है, इसका अपना छत है, अपना घर है, मतलब सीधी. अरे मतलब सर बुरा ना मानो, मतलब आप समझ गए मेरी बात, है ना. मतलब उसका घर है पूरा, नीचे से जमीन से लेके छत तक उसकी है ना, जो भी है वो घर है उसका. अब वो बंदे ने, वो यहां से अहमदाबाद जाता है 300 रुपए में, जो टोल है. That's the affordability point I was trying to make. That's the sustainability point I was trying to make. But sustainability has its own responsibility. Please understand, sustainability has its own responsibility. What do I mean by responsibility in this context? Can we have some opinions, please? Please, sir. Good. Very nice. Very nice. Very nice. Come up. Sustainability has to be balanced. Has to come up with some responsibility. What that responsibility is? Not only of today. Understand? मैं किसी और तरफ ले जा रहा हूँ इस डिस्कशन को. प्लास्टिक जब ऐसा सॉल्यूशन आया था ना, क्यों सॉल्यूशन, फायदे तो हैं. ये मेटल का पेन है, दिस इज अ मेटेलिक पेन, ऑलराइट. प्लास्टिक का पेन हल्का होता है, गुम जाए तो डर नहीं लगता, 10-12 रुपए का आता है, अफोर्डेबल है. बट प्लास्टिक की प्रॉब्लम हम सबको पता है. अब आप अपनी एनर्जी कॉन्शियसनेस में, जो एनर्जी कॉन्शियसनेस की मैंने बात करी है, उसमें ये सोच के मुझे बताइए, मैं फिर बस 10 मिनट और 5-7 मिनट और लूंगा आपके. ये सोच के बताइए कि आज जो एनर्जी ट्रांजिशन चल रहा है, उनमें फ्यूचर प्रॉब्लम्स क्या है.
अवेयरनेस की कमी है, रिस्पॉन्सिबिलिटी की कमी है,
बिल्कुल.
और ईगोस की भी कमी है. ईगो भी बहुत है. व्हाई वी यूज दिस, व्हाई वी यूज दिस.
Even if you wear a jeans के लिए बहुत सारा पानी लगता है.
क्या बात है,
यूज करोगे तो
क्या बात है. प्लीज अंडरस्टैंड, मैं आज रूफटॉप सोलर पावर प्लांट बहुत सारे लगा दूंगा, फिर 20 साल बाद मैं एक क्या हूं, ऑल ऑफ अस आर सेल्फिश क्रिएचर्स. अंडरस्टैंड, वी हैव टू एक्सेप्ट इट, दैट्स द रियलिटी. मैं अपनी बात नहीं कर रहा, आई मीन डोंट टेक पर्सनली, बट एज अ कम्युनिटी, एज अ जनरेशन, all of us are personal self, we like to be related among ourselves. All right, जब ये सोलर रूफटॉप पावर प्लांट बेकार होगा तो मैं इसका क्या करूंगा, मैं इसको प्लास्टिक की तरह फेंक दूंगा. जैसे प्लास्टिक का भी तो कोई हाल किया मैंने. ऑल राइट, फिर ये प्लास्टिक उसी ट्रेन की टॉयलेट को चोक करेगा जिससे मैं अब परेशान हूं. बिल्कुल ठीक बात है. दिस इज the energy awareness I want to bring into you, कि कंज्यूमर एंड पे तो होगा ही होगा, बट कंज्यूमर के साथ साथ सॉल्यूशंस, यहां पे इंफ्रास्ट्रक्चरल पार्ट आता है, दैट वी वर टॉकिंग अबाउट, कि इंफ्रास्ट्रक्चरली जो मैं बैटरी वेस्ट है, जो मेरा ई वेस्ट है, जो मेरे मोबाइल घर पे, सबके घर पे आज 10-10 मोबाइल पड़े हुए हैं. जब 5 साल पहले वो 3-3 होते थे, आज सबके घर पे 2-2 आईपैड, मेरे मतलब बहुतों के घर पे 2-2 आईपैड, 2-2 लैपटॉप, और जब उसको वापस करने जाते हैं तो वो 2000 रुपए बोलता है, दिल नहीं करता, वापस ले आते हैं, है ना, है ना. तो व्हाट इज द सॉल्यूशन? देयर कम्स द इंफ्रास्ट्रक्चरल पार्ट ऑफ इट. सो लेडीज एंड जेंटलमैन, मैं अपने जो की मैसेजेस मेरे को देने थे वो मैंने दे दिए हैं, मैं जस्ट कंक्लूड करता हूँ। एनर्जी ट्रांजिशन का एग्जाम्पल अपने को मिल गया। एनर्जी हर समय ट्रांजिट हो रही है। एनर्जी सिक्योरिटी क्या है? अवेलेबिलिटी, अफोर्डेबिलिटी एंड एक्सेसिबिलिटी ऑफ यूजेबल पावर। ओके, दैट इज एनर्जी सिक्योरिटी। ओके, द सॉल्यूशंस have to come, the solutions have to come as a societal problem. They have to be dealt as a community based solutions. We have to consume our energy wisely and consciously. We have to consume our energy wisely and consciously. सवेरे उठते ही गीजर चला दिया, 4 घंटे तक चल रहा है, थैंक टू द ऑटोकट। अदरवाइज क्या होता, आग लग जाती। ऑलराइट, एंड द फाइनल मैसेज इज, what is my final message? Responsibly deal with the disposition of it. We just cannot throw things onto our children कि यूज तो मैंने कर लिया, फेंक तो दियो, या फिर किराएदार के ऊपर यूज तो मैंने किया, मोबाइल के सब ढक्कन और चार्जर वो फेंकेगा। वो क्या फेंकेगा बेचारा? ही हैज नो, कोई आसमान से कोई डस्टबिन तो है नहीं। तो हमारे पास क्या सॉल्यूशंस हैं? आई थिंक द इंडस्ट्री हैज टू कम अप, द गवर्नमेंट हैज टू कम अप, एंड ऑफ कोर्स द सोसाइटी हैज टू कम अप। दैट्स ऑल फ्रॉम माय साइड, लेडीज एंड जेंटलमैन। लेट्स हैव अ राउंड ऑफ अप्लॉज। थैंक यू। आई विल ऑफ कोर्स, बहुत ज्ञानी मैं नहीं हूँ, कुछ क्वेश्चंस आप मुझे देंगे, कुछ का आंसर भी दे दूंगा। जो नहीं आएगा मोबाइल नंबर बता देना भैया, बात कर लेंगे, है ना? हाँ प्लीज प्लीज, आपसे स्टार्ट करेंगे आप।
जनरल वाटर सिस्टम की 11 kV, 22 kV, 32